Hello, here we go for the video on our uniform acceleration formulae. Now this is a bit further on the velocity time graphs that we were studying, but the entire idea here is that we have uniform acceleration. So the only time these formulae are appropriate is if our acceleration is constant. So there are periods during our velocity time graphs where maybe we were accelerating, then we had a constant velocity, so the acceleration was 0, so the acceleration's kind of changed, and then maybe we would decelerate after that. So these formulae can't be used really over a journey like that, just because the acceleration changes there. So uniform, remember, here means constant. So as long as we've got a period of time where acceleration is constant, then we can use these four formulas. Again, they are derived from our velocity time graphs. It's important to remember what S, U, V, A and T stand for. These are often referred to as the Suvat equations because of the letters S, U, V, A and T. S stands for displacement, so usually how much distance have you travelled in that period of time. U is your initial velocity, so what was your velocity right at the start of that period of time that you're looking at. V is your final velocity, so at the end of that period of time, what's your velocity. And A is the acceleration rate, the constant acceleration rate that you've had throughout that period of time, and T just stands for the time that you've been accelerating for. So let's look at a couple of examples of how we use these formulae. So the first example says a train starts from rest. Now, again, that's quite important, because what that means there then is that our velocity at the start is 0 because it starts from rest, and accelerates with the constant rate of 1.5 meters per second squared. So the acceleration there is 1.5 and it's constant, good, until it reaches the top speed of 30 meters per second. Okay, so it goes from 0 to 30 meters per second, so its final velocity after that time of acceleration is 30 there. Find the time taken to reach this top speed and the distance travelled. So the time taken, honestly, that's kind of like one question, and then the distance travelled is a separate question. They probably should have been written as part A and part B. These are two questions in one. So what they want us to do, first of all, is find the time taken to reach this top speed. So the first thing I do is I write out my Suvat like I've done there, and then I just note down the information I've got in the question and what I want to find out. So in this case, I've got my initial velocity, I've got my final velocity, I've got my acceleration, and I want to work out what the time is, or how long that takes. So I'm interested in the letters V, U, A and T. I'm not really interested in S. So from the letters that I'm interested in, I can notice that the formula V is U plus AT helps me there. And if I do that, then I get 30 is equal to 0 plus 1.5t. So basically you're looking for a formula that includes all of the letters that you either have information on or you want to find out. In this case, for the first part, I wasn't interested in how far I travelled. That's kind of for the second part of the question. So only V, U, A and T there I need. So I can just rearrange this. Now this V is U plus AT to get T is equal to, if I divide 30 by 1.5, that's 20. So that would have taken 20 seconds there to get from 0 meters per second to 30 meters per second if you're accelerating with a constant rate of 1.5 meter per second squared. Now, these formulae here have to be memorized basically, so make sure that you've noted them down and you've got them handy. Okay. So the second part then asks us for the distance travelled. So while it was accelerating, just in that period of time, how far did it travel? So again, what I want to find out there then is how far has it travelled, so it's displacement after that period of time. If it started from rest, reached 30 meters per second, and had that rate of acceleration. Technically, I know the time as well now because I just worked it out, but we're not really interested in it for this part of the question, so I'll cross that out. Each formula has 4 letters in it of the 5. So basically, you look at the letters that you're interested in this case S, U, V and A, and because we've memorised these formulae over hopefully the next couple of weeks, then we'll remember, oh yes, V squared is equal to U squared plus 2AS. So I'll put a top and tail on my S there, so it doesn't look like a 5 maybe. And that is an appropriate formula here for everything that I need. So then my V, my final velocity was 30. So 30 squared is equal to 0 squared plus 2 times 1.5 times S. Stupid cat, shut up. Sorry. 900 is 30 squared is equal to 3 times S. So S being my displacement or distance travelled. Same thing really in this scenario anyway. Is 900 divided by 3, which I get is 300 metres. There we go. So it's travelled 300 metres in that period of time there. Right, so continuing on this, finding out what our S, U, V, A and T is, or which ones we are interested in. You'll have some information in the question, and you'll want to find one out, and then you just use the most appropriate formula of those 4 at the top. Now, another scenario where we have constant acceleration is motion under gravity, because gravity is constant. It's constantly acting down towards the ground, as you've probably found out with a bit of bad luck sometimes, you know. But gravity is always acting downwards, and it's an acceleration. We call it G because it's cool, and it's actually equal to 9.8 meters per second squared. And that's just a constant. Again, you kind of have to remember. However, it's given actually in the front of your, one of the only things actually that's given to you in the front of your examination papers. So we'll be given that, but you'll probably remember it because we'll be using it a lot. So gravity is an acceleration. It acts downwards always at 9.8 meters per second squared. And so in this scenario, I have a particle, probably like a ball or something, is projected vertically with speed 20 meters per second. So I'm assuming it's off the floor. There's a particle that's projected vertically upwards with initial velocity 20 meters per second. Then this particle will obviously travel up until it reaches its max height, and then it'll travel all the way back down until it lands back on the ground again. We've all thrown a ball up in the air before, hopefully. You haven't lived, if not, it's fun. Find the maximum height reached and the time taken to reach the ground again. Okay, so again, this is 2 questions in one. I'm going to look at the maximum height reached first. And the important thing for us to remember is at max height there, if you think about it, if you throw a ball up in the air, it travels up, it's slowing down, slowing down, slowing down, slowing down until it reaches the maximum height. And there's a kind of period in time there where it's not travelling up and it's not travelling back down. So it's kind of still in the air for a split second. So it's velocity at max height. And this only really happens at the maximum height. The velocity is equal to 0. There's a split second where it's not travelling up and it's not travelling down. It's just reached its peak. So V will be 0 there. So when I do my Suvat, there are a couple of things to keep in mind. I've got my S, U, V, A, T. And I'm looking at when does this particle, this ball, reach its max height. So I want to know, oh yeah, how far has it travelled then? If I projected it with 20 meters per second speed, velocity upwards, max height is when it comes to a rest kind of in mid-air, so its velocity will be 0, just before the velocity becomes negative again, before it starts falling back down to the ground. The acceleration, however, is downwards. The acceleration is down towards the ground, so it's actually acting in a negative direction. So because it's against the way of our motion is all upwards here, so acceleration is slowing you down by 9.8 meters per second squared. And for this first part, I'm not really interested in the time taken it gets to the max height. They haven't asked me that. So I'm interested in V, U, A and S. So that is a V squared is U squared plus 2AS formula. Go. Okay. And when I plug my numbers in there, then I've got 0 is equal to 20 squared plus 2 AS, but that is actually going to be 2 times minus 9.8. So that there is minus 19.6 S. Put a top and tail on my S. There we go. There. And now then I can rearrange this. So my minus 19.6 S, if I bring it over here, becomes positive, is equal to 20 squared, which is 400. And so it's just all about rearranging now. So my displacement will be 20.4 meters, 400 divided by 19.6. So that is the max height there if I start off with a velocity of 20 until I come to a rest with gravity slowing me down. There. Okay, next part then is the time taken. So the time taken for it to reach the ground again. So this thing is going to travel up, 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 up. It's going to come back down, 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 down. And I want to know when is it back where it started, basically. So if it's back with where it started, for it to hit the ground again. Hit ground again. That implies, again, okay, the distance it would have travelled is 20.4 meters up and 20.4 meters back down. That's 40.8 meters. However, its displacement, S in my Suvat, will be equal to 0 because it's back where it started. That's a weird 0. It's like a potato. Sorry. So my displacement will be 0 when I am back where I started. So S, U, V, A and T. Remember, for displacement you only really need to compare where did you start off with where did you end up. It's not like distance. So again, displacement, where did I start off? We're on the ground. Where did I end up? Well, on the ground. So technically there was no point in me moving because I'm back where I started. So my displacement then is 0. My initial velocity, however, was 20. A V here would be however fast I hit the floor. I don't really care. My acceleration is due to gravity, so that's downwards, 9.8. And the time it took is what I'm trying to work out. How long did that take to get all the way up 20.4 meters and all the way back down to the ground again? So I'm interested in S, U, A and T. That is S is equal to UT plus a half AT squared. Okay, and then when I do that now, when I have a look at that formula, then S is 0, U is 20, so 20 times time. A half A is minus 4.9 T squared. Try not to divide through by T here. You will have to take a factor of T out. So that's 20 minus 4.9 T. There. And so now then that just tells us that time can be 0. Hang on, what does that mean? Oh yeah, at the beginning of this scenario, when time was 0, the displacement was 0 because he was on the ground. So before it was projected upwards, before he was thrown in the air, right at the start, yes, it was on the ground. So that makes sense, actually. Or, alternatively, so this must be when it lands again. This scenario equaling 0 there. And when I rearrange that, I shall get T is 20 divided by 4.9, which is 4.08 seconds there. Okay, hopefully that's a crack-a-lacking. Thank you very much.